Introduction to sFlow. sFlow is an industry-standard packet sampling technology based on RFC 3176. It is implemented in a broad range of Brocade networking devices from Layer 2 switches to high-end core router platforms. There are three components to sFlow: the sFlow agent, the sFlow collector, and the sFlow generator. The sFlow agent is a software process that runs as part of the network management software within the network element. sFlow agents and routers and switches throughout the network continuously send a stream of sFlow datagrams to a central sFlow collector. The sFlow generator is a network element that generates traffic samples. To minimize the load on sFlow agents, memory, and processor, interface counters and sFlow samples are combined into sFlow datagrams that need little processing. To increase sFlow performance and scalability, Brocade devices implement sFlow agents on the interface modules. This architecture isolates the sFlow agent to the interface modules, which enables high performance without diluting resources from the rest of the system. The sFlow agent uses two forms of operation: time-based sampling of interface counters and statistical sampling of switched packets. The sampling rate for interface flow sampling is adaptive. The sFlow agent is free to schedule the sampling in order to maximize internal efficiency. Within given sampling rates, the Brocade processor randomizes the capturing of packets. This ensures that sampling is more accurate and comprehensive in capturing flow information. The sFlow collector software analyzes the datagrams received from each sFlow agent and presents a real-time, network-wide view of traffic flows. This provides detailed insight into network traffic patterns, link utilization, and overall network performance and traffic profile discovery. The data received on the NetFlow collector can be crucial in detection or prevention of many network issues such as denial of service attacks, port scans, virus and various TCP flag or signature-based attacks. sFlow has many benefits in terms of accuracy. Because sFlow is implemented in hardware at wire speed, a high degree of accuracy is achieved. Unified technology. Users can obtain detailed information from Layer 2 through Layer 7 on all flows. Protocols such as IP and MPLS are supported. Scalability. Since sFlow has a low impact on the router or switch's performance, all speeds of links can be monitored, including 10 gigabit per second and above. The sFlow technology also scales to monitor tens of thousands of flows over several hundred ports on the switch. Deployment ease. sFlow can be easily deployed on existing networks, and configuring sFlow is simple. Several vendors offer sFlow collector software that can create accurate network views. Minimal network load. sFlow is non-intrusive in a network. The sFlow packet overhead is less than 0.02% for a 10 gig Ethernet link, even with aggressive sampling rates. Real time. Since sFlow is sampled in hardware, changes in flow rates are reflected in real time in the flow statistics. sFlow can be used to help solve many real-world problems. A few examples are, in the case of network outages, sFlow can monitor thousands of ports in a network to accurately pinpoint reasons for network outages or why traffic on a server is slow. For traffic monitoring, sFlow provides real-time statistics of traffic on the network, including bandwidth used, protocols, connections, and more. Network planning. Historic traffic usage trends can be used to determine network capacities for planning purposes. For intrusion detection, sFlow can help recognize network-based attacks. For profiling routes, traffic flow rates for each route can be determined with the help of sFlow data. And for accounting and billing purposes, sFlow can provide detailed statistics about applications in use on the network. In this demo, we will show you how easy it is to configure sFlow on a Brocade switch, and then we will verify the sFlow information from our switch as well as from network monitoring tools. So let's start. Here we have a 48-port ICX lab switch. To begin, we go into the config mode and define the sFlow configuration. Please note that fast iron devices support sFlow version 5 by default. To specify an IPv4 address as the sFlow agent IP address, enter a command like the following: sFlow agent-IP and then the IP address. in this case 10.18.233.50. To specify an sFlow collector on an IPv4 device, enter a command sFlow, destination, and then the IP address. In this case, 10.120.14.135. With sFlow version 5, we can specify the maximum size of the flow sample sent to the sFlow collector. If a packet is larger than the specified maximum size, then only the contents of the packet up to the specified maximum number of bytes is exported. If the size of the packet is smaller than the specified maximum, then the entire packet is exported. For example, to specify 1024 bytes as the maximum flow sample size, sFlow max-packet-size 1300. To export CPU usage and memory usage information, enter sFlow export system-info. To enable the sFlow agent on a Brocade device to export data destined to the CPU to the sFlow collector, enter the following command: sFlow export CPU-traffic. To globally enable sFlow forwarding, enter the following command: sFlow enable. To enable sFlow forwarding on a few interfaces, define and range interface Ethernet 1/3/1 to 1/3/8, and then enable sFlow forwarding with the following command: sFlow forwarding. Now with the help of show sFlow, we can verify the information that we've just configured. We can see that sFlow version 5 is enabled on this device with the configured sampling rate. We can also see the interfaces enabled for sFlow. For this demo, we're using an sFlow collector application called sFlow Trend from Nmon. This application is already configured to receive the sFlow data from the ICX switch that we had just configured. We've configured two types of events to monitor our ICX stack uplink ports. The thresholds available are utilization, unicasts, broadcasts, multicasts, errors, and discards. We're interested in utilization and unicasts. For this sFlow collector application, we'll set up email alerts when the configured thresholds are reached or exceeded. So here we see that we have successfully received a test message from the application. To verify the two events that we're monitoring, we can see that when the configured threshold is reached, we will receive an email. The same is true with the other event, which is related to unicast. As we can see from the traffic counters and traffic stream statistics, the network seems to be experiencing a lot of traffic, and this could possibly be due to a denial of service attack or unusually high amount of traffic due to some issues going on. We can also see the top interfaces by total frames on the switch. There are no errors or discards on any of the interfaces. Now, if we wait long enough, this screen will update and we will be able to see the top interfaces by utilization as soon as the collector application calculates the amount of traffic during a given time interval. The unicast threshold is already showing as red, and soon enough we'll receive an email alert. The email messages are tied to a denial of service attack on our ICX uplink ports. The email messages were received for all 8 of our uplink ports that sFlow was monitoring. The one thing you have to watch out for is that sFlow trend data can fill up your inbox. For example, if you would have let this denial of service attack go on. If we wait for a few more seconds, we will now see that the utilization threshold is also showing as red for all interfaces. And as you can see, this is immediately followed by an email alert. In order to now further drill down and find out what kind of attack we're seeing and where the attack is coming from, we can see the tool tells us the root cause factors of both of the criteria violations that we had set earlier. This will give us an idea where the problem is and how we can eliminate the offending host from the network. This concludes our brief demonstration of sFlow. As you can see, sFlow is easy to configure and provides powerful data for analytics of many aspects of network traffic. We encourage you to enable sFlow for yourself and explore the wonderful capabilities that this tool provides. Thank you for your time.